Article 810 of the National Electrical Code covers the grounding and bonding of communication systems, including satellite dishes. Section 810.21 provides general requirements stating that communications equipment, which includes satellite dishes, must be grounded and bonded as per this article. Section 810.41 specifically addresses satellite dishes, mandating that each dish must have a ground ring installed around it. This ground ring should extend at least 12 inches beyond the dish's perimeter. Section 810.42 details the grounding of these ground rings, specifying that each ground ring must be grounded to the grounding electrode system. The grounding electrode conductor's size must comply with Table 250.66. Section 810.43 addresses the bonding of the ground rings. It states that all ground rings must be bonded together. This bonding must be done using a bonding conductor, with the size of this conductor determined by Table 250.66. The purpose of grounding and bonding, particularly in the context of satellite dishes, is to provide a safe path for electrical fault currents to return to the source, reducing the risk of electrical shock and equipment damage. A ground ring serves as an equipotential plane around the satellite dish. This ring minimizes voltage differences in the immediate vicinity of the dish. This helps to protect both equipment and personnel. The extension of the ground ring at least 12 inches beyond the perimeter ensures comprehensive coverage. It captures any stray currents for potential differences that might arise. Grounding each ground ring to the grounding electrode system, as stated in Section 810.42, ties each dish's grounding system to the overall building or facility grounding system. This connection ensures that any fault current has a direct path to ground. This minimizes the voltage potential between the dish and other grounded objects. Table 250.66 in the National Electrical Code provides guidelines for sizing the grounding electrode conductor based on the size of the service entrance conductor. The specifics of this table should be consulted to determine the appropriate conductor size for the particular installation. Bonding all the ground rings together as described in Section 810.43 creates a common ground potential between all the satellite dishes. This equipotential bonding prevents circulating currents and voltage differences between the dishes. It ensures that any fault current is shared and directed safely to ground. Again, Table 250.66 is used to determine the size of the bonding conductor. The selection of the appropriate grounding electrode system is also crucial. Common grounding electrodes include metal underground water pipes, metal frames of buildings, concrete encased electrodes, and ground rings. The choice depends on site conditions and the availability of suitable electrodes. The grounding electrode system should have a lower impedance path to ground to facilitate the rapid clearing of fault currents. Proper installation techniques are essential for effective grounding and bonding. Connections must be made using approved methods and materials. These must be suitable for the environment and designed to withstand corrosion and mechanical stress. Ground clamps and connectors should be listed and labeled for grounding purposes. They should be installed according to the manufacturer's instructions. Regular inspections and maintenance of the grounding and bonding system are necessary to ensure its continued effectiveness. Connections should be checked for tightness and corrosion. Grounding conductors should be inspected for damage. Any issue should be addressed promptly to maintain the integrity of the grounding system. It is also important to consider the specific environment in which the satellite dishes are installed. In areas with high lightning activity, additional lightning protection measures may be necessary. These measures can include lightning rods, surge protective devices, and additional grounding electrodes. In corrosive environments, the use of corrosion-resistant materials for grounding and bonding components is crucial to prevent degradation and ensure long-term performance. The National Electrical Code is updated regularly, so it is essential to stay current with the latest requirements. Understanding and adhering to Article 810, as well as other relevant sections of the Code, is critical for ensuring the safety and reliability of satellite dish installations. Proper grounding and bonding not only protect equipment and personnel, but also help to maintain the integrity of the overall electrical system. The intent of the National Electrical Code with respect to grounding and bonding is to create a low impedance path for fault current to return to the source. This path facilitates the operation of overcurrent protective devices such as circuit breakers and fuses to quickly clear the fault. A properly grounded and bonded system also minimizes voltage differences between conductive parts. It reduces the risk of electric shock. Grounding and bonding are not the same thing. Grounding refers to connecting the electrical system to the earth. Bonding refers to connecting metallic parts together to create a common electrical potential. Both grounding and bonding are essential for electrical safety. They work together to provide a comprehensive protection system. In the case of satellite dishes, the ground ring provides a localized grounding point for each dish. Bonding of the ground rings together creates an equipotential plane that encompasses all the dishes. This ensures that all the dishes are at the same electrical potential. This minimizes the risk of voltage differences and circulating current. The grounding electrode conductor connects the ground rings to the grounding electrode system. This connection provides a path for fault current to flow back to the source. The size of the grounding electrode conductor is determined by Table 250.66. This table takes into account the size of the service entrance conductors and the type of grounding electrode used. The bonding conductor connects all the ground rings together. The size of the bonding conductor is also determined by Table 250.66. It's crucial to use approved connectors and methods for making grounding and bonding connections. These connections must be mechanically sound and electrically conductive. They must also be resistant to corrosion. The National Electrical Code provides specific requirements for grounding and bonding connectors and methods. Regular inspection and testing of the grounding and bonding system are important to ensure its effectiveness. This includes checking the tightness of connections, the condition of conductors, and the resistance of the grounding electrode system. Any deficiencies should be corrected promptly. In addition to the requirements of Article 810, there may be other applicable codes and standards that apply to satellite dish installations. These may include local building codes, electrical codes, and industry standards. It is important to be aware of all applicable requirements and to comply with them. Grounding and bonding are complex topics, and it is always best to consult with a qualified electrical professional if you have any questions or concerns. A qualified electrical professional can assess the specific installation and provide guidance on the appropriate grounding and bonding methods and materials. They can also perform inspections and testing to ensure that the grounding and bonding system is properly installed and maintained. Proper grounding and bonding is essential for the safety and reliability of satellite dish installations. By following the requirements of Article 810 of the National Electrical Code and consulting with a qualified electrical professional, you can ensure that your satellite dish installation is properly grounded and bonded. This will help to protect equipment and personnel and to maintain the integrity of the overall electrical system. The location of the satellite dishes in a remote area without nearby buildings does not change the fundamental requirements for grounding and bonding. Each dish still needs its individual ground ring. All ground rings need to be bonded together. This is because the purpose of grounding and bonding is to protect the equipment and personnel at each satellite dish location. The absence of nearby buildings does not eliminate the risk of electrical faults or lightning strikes. In fact, remote locations may be more susceptible to lightning strikes due to the lack of surrounding structures. Therefore, it is even more important to ensure that the satellite dishes are properly grounded and bonded in remote areas. The grounding electrode system should be appropriate for the site conditions. If a metal underground water pipe is not available, other options, such as a ground rod or ground ring, should be used. The grounding electrode system should be installed in accordance with the National Electrical Code and any other applicable codes and standards. The bonding conductor should be sized according to Table 250.66 and should be connected to each ground ring using approved connectors and methods. All connections should be mechanically sound and electrically conductive. Regular inspections and maintenance of the grounding and bonding system are especially important in remote areas where access may be limited. This includes checking the tightness of connections, the condition of conductors, and the resistance of the grounding electrode system. Any deficiencies should be corrected promptly to ensure the continued effectiveness of the grounding and bonding system. In summary, the requirements for grounding and bonding satellite dishes are the same regardless of whether they are located near buildings or in remote areas. Each dish must have a ground ring. All ground rings must be bonded together. The grounding electrode system must be appropriate for the site conditions. Regular inspections and maintenance are essential.